Okay, so welcome to this DCG 2023 question B2. Right, we've got surfaces A, B, C, D, C, B, E, F, and they're intersecting. Alright, draw the given plan and elevation. Okay, determine the dihedral angle between the two planes. Okay, so find the angle between the two surfaces. Part C, okay, we'll talk about in a few moments. We'll have a quick look in 3D. Okay, so what it's looking like there's the two planes and the two surfaces. We've got our elevation there, we've got our plan view, and we have to find the dihedral angle between them. Okay, so we need to look along the line of intersection, okay, BC, and get both planes projecting as edge views, and then we'll see the dihedral angle between them. Okay, it's down to 75 there. I round it to 70, 76 I think when I do it. Now, to find the dihedral angle, we're going to have to, on our piece of paper, we're going to have to look along, alright, the true length of the line of intersection. You can't look immediately along a line on your sheet of paper to see it as a point. It just won't work. You need to look along a true length line to get the line of intersection as a point. So look perpendicular to it. Now, part C, point P is on the edge, BC. Locate a true distance of 55 from point B. Draw the plan elevation of a line D to P and determine the true length of the line D to P. So I can get the true length of line BC, okay, mark 55 in it. You can rotate it in plan, so rotate it parallel to the XY line, put the point on the line and rotate it back in elevation, which is just going horizontal, where is it? Horizontal there until it hits BC again, and then join it back. Now, there's a simpler way of just bringing it from the auxiliary, because the line of intersection is the true length. Get the plan view of our line DP, rotate the line until it's parallel to the XY line in plan. Okay, and this will be, then bring it across an elevation, this is our true length. Now, to get the, true angle between line, AB and BF, we're going to have to create a plane. And we're going to have to get that plane to project as an edge by using a strike line, a horizontal line. Look along that line from plan, get the plane, or get it to project as an edge. And then we can project off our auxiliary to get our true shape of our surface. So if we get the true shape of our surface, and when you see two lines as true lengths, on the plane, and the surface has a true shape, you can get the true angle between. Now, I'm going to start by beginning to draw this. So it's a bit different to our normal, alright, with drawing, these dihedral angle questions. We don't know where point A is in plan view. We don't know where point A is in plan view, but what we do know is BC is parallel to AD in elevation, and parallel lines are parallel in every orthographic view, and they tell us to draw the given, or to give us a hint, draw the given plan and elevation. So we'll start with the plan first. Now there's 16 marks going for part A in that particular year. So we draw in our XY line. Okay, we'll pick a point down to go with for 25 degrees that you can see here. So mark in our 25. Okay, now we're going to mark 55 along that line, because it's the same as this one. Okay, then we'll use our sliding set squares. And we're going to mark 80 along this line here, because F, E, / E, C and B, so 80. So we'll do the first one at 50 to get point C. So there's point C and there's point B. So there's F / E, B. Alright, now our angle there, okay, is 75 degrees for point D. So there's point D. Now, we don't know where point A is in plan, but if we get our elevation of it, it'll get us our answer. So I can project my existing points from plan up. So D is on the XY line elevation, so too is C. Okay, B is above the XY line. The altitude of B, okay, is 85 from the XY line. F is 50, B is a further 35, so an altitude of 85. There's B, there's F, now A is an altitude of 60, okay, from the XY line. So I'm going to mark in horizontal line 60 mil from the XY line. I'm going to join B to C in elevation. Now parallel lines are parallel in every orthographic view, so BC and AD are parallel. So I'm line my set square up with BC. I'm sliding it up here, so here's point A. I can join A to B. Now, I'm going to get the plan view of point A by dropping it down. And where it hits this line, run through D. So this one, that's where point A is. And I can join A to B. And A to D. Now, okay, we're going to look at doing part B. So, determine the dihedral angle of the planes, okay, between the planes ABCD and BCEF. Here are your questions to ask. Is LOI, length of, or line of intersection, a true length in elevation? No, because it's not parallel with the XY line. It's not parallel with the XY line in plan, so it's not a true length in elevation. Is it a true length in plan? No, it's not, because it's not parallel to the XY line in elevation. So find TL. Then, key word being then, look along TL, because so many students just immediately look along the line of intersection. A lot of my students in this year's mock exam done that. So find the true length first. So to find the true length, okay, we're going to look perpendicular to line BC, okay, from in plan or elevation. I'm going to do it in plan, but you can do it in plan or elevation. Okay, so we're going to look perpendicular to line BC, okay, in plan, and then we're going to get our heights from elevation, because we're taking, okay, we're doing an auxiliary elevation. We're projecting an auxiliary elevation from plan. Now, you can do all the points there. We draw in our x1 and y1 line. And I'm also going to mark in a datum line parallel to the x1 y1 line while I'm here, because I know I'm going to need it later for taking my secondary distances. Now, so I can take my heights from elevation, right? I know the height of point A is 60 millimeters if you look at that in elevation. So instead of just using your compass, you can mark in A1 there. I know B has an altitude of 85. So I'm going to mark in 85 there. B1. I know F has an altitude of 50. So I'm going to mark in 50 there. Now, D, I know is on the X1 or XY line elevation. Okay, so too is E. And I just have to project C as of yet. And C1 is on the C is on the XY line in elevation. So that projection line came from B if it was missed in the camera. Now, so we're going to join B1 to F1. B to C. Here's the true length. Okay, F to E. B1 to A1 as hidden detail, and A1 to D1 as hidden detail. Now, I have to look along my line of intersection. Sorry, oh no, that's the right angle there. So I'm going to look along my line of intersection. So I'm projecting along line BC. Now you don't need to take all the points. Look, take point D and point E. You only need to take the line of intersection and a point on each surface. I'm going to draw in my X2, Y2 line. And using my compass, I'm going to take my distances from my datum line back to plan. So there's BC projecting as a point. Point E is going to be the same distance as their parallel. Okay, and then we just need, okay, the distance of D. So D there, and I'm going to project from the projection line from D. And now, so this is the two surfaces projecting as edge views. You can see them projecting as edge views there. So we have an edge view of one surface. Here's the other one. And here's our dihedral angle here. Okay, so I'm getting 76 degrees in my drawing. Okay, and see what I got here. It'll come up with 75 there. Just want to see what was the exact value. 75.82. So yeah, 76 degrees, absolutely perfect. Now, part B, or part C rather, draw point P is a point on the edge of BC, which is located at a true distance of 55 from point B. Draw the plan and elevation of line DP, determine and indicate the true length of line BP. Right, line BC is not a true length in elevation or plan, so we can only apply the true this 55 millimeters for point P when we see the true length of line BC. Now, what I done here in SolidWorks is I rotated the line and located, okay, point P on the true length, which is 55 along there, 55 along this line right there, and then I rotate it back around. Now, to be fair, you already have the true length here, so you could mark 55 here and bring it back down. We'll look at, we're just quickly doing the two. It's not going to take that long, so it's not. So I could draw a horizontal line from B in plan. Okay, get BC, rotate BC in plan until it's on that horizontal line. Bring BC up. Here's the true length of B to C. Then you can mark 55 along that line, and you can simply bring it back to elevation. Okay, you can simply bring it back. So there's point P, and then join D to P. So this is D. So join D to P in elevation. Find the plan view of this line, D to P. So drop this down. Apologies if you can hear that horrendous music in the background in school. Now there's P in plan. Okay, now you could also, okay, set your compass to 55 and swing an arc up here, because it's on a true length line there, and you'd project it back down from your auxiliary elevation, and they'd intersect there. You could also do that. Okay, now we have to find the true length of line, determine and indicate the true length of line DP. So if I get line DP parallel to the XY line in plan, it becomes a true length in elevation. So I'm going to draw a horizontal line from DP, or from D rather. I'm going to rotate P onto that line. I'm going to bring P1 up. So I'm going to bring P1 up and then P across. And then I'm going to join that back to K, D, P. Here's the true length, and it says determine and indicate. So it says determine and indicate. Okay, so we're going to do that now. So 67 millimeters. It's our true length. Now, our last one. Alright. Determine the true edges between AB and BF. Right? The only way you can see the true angle between two lines is, okay, to see them both as true lengths at the same time. And the surface they rest on, you want to see as a true shape as well. You could, some students could end up rotating AB in elevation, bringing it across there. Do the same with BC, they've already done, or sorry, BF, up and across, and they think they have it there, but they don't, because you've rotated both the lines. So it's not the same angle between them anymore. So to get this, I'm going to have to join A to F. I'm going to draw a straight line across from A. I'm going to project it down. And I'm going to look along my straight line and get that surface to project as an edge view. So here you can see it in 3D. There's my straight line. Here's my straight line. There's the surface I created. I'm going to look along that and get an edge view and project perpendicular to it to produce an auxiliary that shows the true shape of the surface, and then that's the true angle up there. So like you see here, look, straight line, look along it, the line is going to project as a point, the surface projects as an edge, look perpendicular to the surface. Okay, and then you get the surface, AFB is a true shape, and lines, every line on a true shape is a true length. So AB is a true length, FB is a true length, and then the true angle will appear between them. So we're going to do that now. I happen already to have a horizontal line drawn through A, so I'm going to drop that down. I'll call that M. I'm going to join A to F. I don't actually need to, but I want to do it to help understanding. So I'm going to join A to F in plan. Okay, now here's M in plan. So I'm going to look along line A to M. I'm going to project F as well and point B. There's just the whole projection lines I just want to get out of there. Okay, now I have another XY line. So my X1, Y1 line. I'm going to get my height from elevation. So I know the altitude of F is 50. I know the altitude of B is 85. So I'm going to mark in 85. I'm going to join them together. So this is B1. This is F1, and that's A1 slash M1. Now, I'm going to look perpendicular to the surface AFB. So I'm going to draw in an X2, Y2 line. My projection lines are at a right angle to it. And I'm going to take my distances from my X1, Y1 line back to plan. So X1 back to B. I'm going to put it here. X1, Y1 line back to F. Put it here. X1, Y1 line back to A. Put it here. Just continue this projection line. Now, this is B2. Okay, that's A2. That's F2. So A and F joined together with a line we created. Okay, B and F joined together. Okay, and B and A joined together. So the true angle between the lines, okay, is here. Angle of, well, I got 60 and a half. So I think it's down in the marking scheme is 61. So there'd be no issues with that. True angle. And what I get in my SolidWorks. .83. Right, so going over it again. Part A was fairly handy to do. Only difficult part was letter A, parallel line in plan. Parallel lines are parallel in every orthographic view. Sorry, I shouldn't actually say that term. Okay, because line AB and BC are not parallel in plan. I should say the question tells you that in elevation, line BC is parallel to line AD. So I was able to find A in elevation, hit an altitude of 60, drop down to plan. Then for our dihedral angle, check is line BC a true length in plan and elevation. It's not. So find the true length of the line, look perpendicular to it, then look along it to get your dihedral angle. Okay, for part C, to locate point P, you need somewhere where you have the true length of line B to C. And when you have the true length line B to C, you can go 55 from B to mark P. So you can do it in a rotational line or in this auxiliary and bring it back. Then rotate the line D to P until it's parallel to the XY line in the plan and bring it up. And then the true part D, to find the true angle between lines AB and BF, I need to see the true length of both lines at the same time, and the surface they rest on has to be a true shape at the same time. So I joined A to F to create the surface, ABF. I drew a horizontal line on that surface, a strike line. I found the plan view of my strike line. I looked along the strike line because the strike line was the true length and it was going to produce the surface as an edge view. And then I could look perpendicular to the surface and I get the surface as a true shape and both planes as the true length. And then I'd have the true, or both lines as true lengths. And then I'd have the true angle between the lines. Thank you.